Welcome to the Deep Dive. We take your source materials, dive deep, and pull out the key insights for you.
Yep, we cut through the noise, try to make sense of the complex stuff.
And today, we're tackling something really critical: the intersection of AI, artificial intelligence, and the future of our planet.
That's right. We're working from materials provided to us, specifically drawing from the Problem-Based Learning Lab, which is part of Project Plain Talk.
Okay, and these materials, they really pose a big question, don't they? Can AI help us fix the planet's environmental mess?
Exactly. But also, what's the cost? What's the catch? So our mission today is to unpack that relationship using this material, look at the potential, but also the challenges.
All right, let's get straight into it, because the context the material provides, it's pretty sobering. It paints a picture of Earth undergoing some massive changes.
It really does.
Yeah.
You know, for about 10,000 years, we had this period called the Holocene, really stable climate.
The time when human civilization really took off.
Precisely.
Yeah.
But the material makes it clear. We're not in the Holocene anymore.
We've moved into the Anthropocene, is the term used.
Yes, the age defined by human impact. And it's not subtle impact, is it? We're talking rising global temperatures, melting ice, sea levels going up.
And all the extreme weather we keep seeing. The wildfires, floods, heat waves. It feels constant.
It's a fundamental shift. And the material gives us a way to measure this, thankfully. It introduces the planetary boundaries framework.
Right, developed by Johan Rockström and his team. What's the core idea there?
Well, they identified 9 key Earth systems, things like climate change, biodiversity loss, freshwater use, that regulate the planet's stability.
Okay.
And for each one, they tried to define a boundary, a limit, within which humanity can operate safely. It's like defining our planet's safe operating space.
A safe zone. But the data in the material suggests we're straying outside that zone quite a bit.
Alarmingly so. The trend is what's really concerning. The material shows back in 2009, we'd crossed 3 of the boundaries they assessed then.
3 out of 7 back then, okay?
Yeah. By 2015, it was 4. And then the latest analysis from 2023, looking at all 9 boundaries.
Yeah.
We've crossed 6.
6 out of 9. Wow, that's moving fast in the wrong direction. Puts incredible strain on the systems that support us.
It absolutely does. And there's another metric the material uses that really hits home. Earth Overshoot Day.
I've heard of this. Explain it for us.
Sure. It's basically the date each year when humanity's total demand for ecological resources, food, water, timber, carbon absorption, exceeds what the Earth can actually regenerate in that entire year.
So it's like we have an annual ecological budget, and that's the day we blow it.
Pretty much, yeah. From that day on, for the rest of the year, we're effectively running an ecological deficit. We're borrowing from the future.
And the trend there is also worrying, I assume?
Oh, definitely. The material points out that back in 1970, Earth Overshoot Day was December 30th. We almost made it through the year sustainably.
December 30th. That's incredible.
Yeah.
And now, what does the analysis say for this year, 2024?
August 1st.
August 1st. So 5 whole months, August, September, October, November, December, operating in the red, ecologically speaking.
Exactly. It's what the material calls the risk of leaving a bankrupt planet
Yeah.
for future generations. It raises huge ethical questions, you know.
For sure. Questions about fairness, especially for the global south, as the material notes, and the need to maybe blend traditional knowledge with tech.
Yeah, indigenous wisdom alongside modern tools, which actually brings us nicely to the other side of this coin, AI.
Right, because the same material that paints this bleak picture also positions AI as a potential game changer.
And the potential is genuinely vast. The document lists so many areas. Speeding up the transition to clean energy, better climate modeling, making education more accessible, designing sustainable cities, transforming agriculture.
Helping with resource scarcity, pollution, inequality, the list goes on. AI can process information and find patterns in ways humans just can't.
It can amplify our own capabilities, essentially. A powerful tool, potentially, for navigating those planetary boundary issues we just talked about.
Okay, sounds promising. But here's the twist, the paradox the material highlights. This powerful tool, it comes with its own significant environmental costs.
Exactly. The energy footprint of AI is becoming a really big deal, especially with these massive, complex models we're seeing now.
The material gives some examples to try and make this tangible, right?
It does. It mentions, for instance, that a single Google search uses about the same energy as an old incandescent light bulb running for like 10 seconds.
Okay. That's maybe smaller than I'd think, but it adds up with billions of searches.
It does. But then it contrasts that with something much more complex, like a query on a large language model, say ChatGPT.
Okay.
One single query like that uses roughly the energy equivalent of running a laptop for a full 12 minutes.
12 minutes for one query, and think how many millions, billions of those are happening constantly.
Exactly. And it's not just queries. AI is being built into everything: healthcare, finance, cybersecurity, manufacturing, cloud services.
Which means a huge increase in demand for computing power.
Massive surge. And that means more electricity, often from fossil fuels, and also huge amounts of water, mainly for cooling the data centers where all this training and processing happens.
So quantifying the exact total impact is hard, the material says, but it's definitely a major concern.
It's a significant and growing one, yeah. We can't ignore it.
And there's an economic dimension, too, touched on in the source. AI is projected to add, what, almost $20 trillion to the global economy by 2030.
Huge numbers. And the material links this to energy, pointing out how access to energy often correlates with economic output, using the US and India as an example comparison.
So AI's hunger for energy is tied up with economic growth, global development, maybe even shifts in global power.
It's all interconnected. And the big challenge is, how do we harness AI's economic potential without completely wrecking the planet's ecological budget?
Which really brings us to the core distinction the material wants us to grasp. Sustainable AI versus AI for sustainability. They sound similar, but they're different things.
Absolutely crucial difference. The material explains sustainable AI in a couple of ways, but settles on a more focused definition to avoid confusion.
Okay, let's stick with that focus definition then. What is sustainable AI?
So in this specific sense, sustainable AI, or you might hear it called green AI or eco-friendly AI, is all about reducing the negative environmental footprint of the AI technology itself.
Right. So making the AI tools, the models, the infrastructure less damaging to the environment, cleaning up AI's own house, basically.
Exactly. Throughout its whole life cycle design, manufacturing, running it, getting rid of it eventually.
And how do you do that? What are the examples given?
Things like designing AI models to be more efficient, so they need less data and less computing power to train and run. That means faster results, less energy used.
Makes sense.
Also, better data practices, like sharing data sets instead of everyone processing the same stuff over and over. Running data centers on renewable energy, obviously. Developing smarter water-saving cooling systems. And even pushing some AI processing out to edge devices, your phone, a sensor, instead of always relying on those massive energy-hungry data centers.
Got it. So sustainable AI is about the how we build and run AI responsibly. So then what's AI for sustainability?